ChatGPT and Copilot and GPT-3, they're incredibly exciting and incredibly inspiring and useful in various forms.
Yeah.
I think the headwinds for them in this regard is that these are ultimately like big statistical models around language and tokens, etc. But this focus on generative problems, I think, is very smart.
Today I'm joined by Richie Stebbing, who earned his PhD in engineering science with a focus on computer vision from Oxford. We originally met years ago at a private salon of roboticists and ML and AI practitioners who gather in San Francisco to learn about frontier technologies from academic and industry experts. This episode is all about language and technology, specifically Richard's study of Vietnamese, his interest in large language models, his prior projects in recovering 2D and 3D structures from images and videos, his most recent work on transformer-based models at Impira, and the recent acquisition by Figma and the new areas he's excited to contribute to. It was a joy to explore these topics with Richie, since he's a rare combination of an expert who approaches the world with a beginner's curiosity. I hope you enjoy listening to our conversation. You were mentioning just downstairs about learning Vietnamese.
Oh, yeah. So,
what's that process?
I embarked on it, I think, like 55 or 56 days ago, just using Duolingo, which has been pretty fun. But the fun part about it, just kind of language-wise, again, for someone who only speaks English and who's from New Zealand, so vowels are always challenging for us anyway.
Right.
Vietnamese is interesting because of the fact that the vowels are, they have more vowels,
right,
and then they have all of the tones on top of these.
Right.
And so really kind of, it's been fun just kind of to relearn how to learn again, and also just really kind of understand the value of kind of talking through things. And I've had to kind of relearn to read almost because I can't rely on like silent reading,
right?
Because I'm reading it as if it's English, which it's not. It's just you lose. You it's a different alphabet, and so it's just been fun to
so
kind of.
Does she think you speak Vietnamese like a Kiwi, or?
Yeah. I've had some good compliments. I've also had some blank stares at times where I've gotten the tones kind of slightly wrong.
Right.
It's just like English. There's some words where, from the perspective of, there's some words where a letter or a sound that's slightly different can radically change the meaning.
Yeah.
And there are some things that from the outside just seem kind of funny to me, but then we have the exact same things in English too. So
right.
A lot of swear words are like adjacent by like a few letters to something else, which is just pretty funny.
So you accidentally like curse her out and
yeah. There's some seriously bad words that are near other words that you might want to say, and so now I've just been learning variations so that I don't even kind of tread.
Right. Just don't go close to it.
Yeah. So it's been fun and just.
And you started with Duolingo with zero knowledge of Vietnamese. You just.
Yeah. It's been interesting though. I think I started with that, and then they basically drop you straight into. So it's been fun. It's the first time I've used this application, and my girlfriend uses it for like, I think Spanish, but she speaks French, English and Vietnamese. And so it was interesting because dropping into it, first of all, the experience can be like quite different between languages, which I wasn't aware of. Like in Spanish, the kind of curriculum is set up so they do like a lot of back and forth in terms of like conversational type pieces, whereas on the Vietnamese side, there's kind of a set sort of, at least what I've gotten to so far. Maybe it changes as it goes further through. And I'm also not
meaning like it's a sequence where you're building up.
Yeah, the way it's structured is they have I think they're called lessons or stages, but there's kind of big blocks of them, and what they I'm sure, again, someone who knows more about the application and also like learning can use all the right terminology, but the way it's set up is such that they sort of try to introduce a few things, and it's all done through full sentences. And they'll do things like introduce a new bit of vocabulary, then they've got all these different kinds of exercises. So they'll have one where, for example, they'll have just the sounds on the left and you have to match it up to say like the English word on the right. They have others where they'll say everything in Vietnamese and you have to write it down in Vietnamese. They'll have ones where it's just written in Vietnamese and you got to give the translation in English. So there's these different variants. And so I sort of just jumped into the first lessons and started just butchering my way through it. Which initially was fine because my vocabulary set was so small, me treating, every kind of O or A as the same was fine because I didn't know what else it would conflate with. But the reality is in the full language, these things are actually very, very close. And so kind of what happened after a few weeks was I was feeling like I was making sort of good progress, but ultimately I kind of had to relearn at one point and actually slow down a lot. So now I actually just like speak through each exercise as I go through it. But each lesson is kind of cool because they sort of introduce some new things. They do revision of what's previous so that you sort of obviously kind of don't lose it and don't forget it, but also just to kind of reinforce things over, over days, what it ends up being, which is very helpful. And then so it introduces on the phrases point. I think it would be very difficult to learn though without someone to be able to talk to and get feedback on that side. I've also had to like supplement it a little bit with some YouTube videos around how to pronounce different things. Again,
but you're in YouTube, you're still just consuming, right?
I'm still just consuming.
Do you have a two-way way to do this?
Only with my girlfriend. She's the only one who gives me feedback, and
she's a native speaker.
She's a native speaker, so that works totally fine. But it's been just interesting to kind of re-go through this. But it's and I say re-go through it meaning just like I feel like I've had to, at least I learned English by reading out loud and then reading silently. I've had to do exactly the same thing.
Are there any places you can go where you could, like, I don't know, a group that maybe meets up in San Francisco to hang out?
That is a good idea.
Because I used to, when I was learning Spanish in high school and college, and in college we had a thing called intercambios where you would hang out with a bunch of other people, mostly who are also learning, but some who are little ways ahead of you. So if you forget a word or don't know a word, they can sort of chime in.
Yeah, I haven't looked into anything like that. I feel like right now I'm operating not at real time. So a sentence gets said,
right,
and I take longer to kind of re-go through it. And
well, you're only 2 months in, right?
Yeah, exactly. No, I'm like super noob. I mean, the goal is just to like keep this up and keep kind of digging. And honestly, it's just fun. Like it's fun learning a new language, the different expressions of different concepts. Like I used to think when I was like much younger that like your thinking, etc., was all very kind of independent of language, but that's just not true at all.
Right.
Like,
where do you find, like, are there examples where you've noticed things about, maybe you noticed something about how you think because of the way that a different way of thinking would suggest?
The one that comes to mind to start with is not super deep, but I think is still interesting, which is the fact that the way you refer to yourself differs in the context of who you're talking to.
Right.
And
we don't really have that in English.
No, you just say I. Like, I did this or I went there. Like, if you were talking to your parents about where you went,
right,
it might be very similar to if you're talking to like your friends. Slang and formal words aside, like, but the fact that you refer to yourself as I and them as like you, Vietnamese is different. It's very contextual, and there's some parts around, like, from my understanding so far, which again hopefully isn't wrong, but
2 months in,
is this it's like the perceived relationship between the two, and I think that's just pretty interesting. And from what I've understood, it's
the perceived relationship, meaning like a familial relationship or kind of a power
exactly.
dynamic,
like, so say for example, like someone may be referred to, the same word used for older brother might be referred to for a spouse, for a male spouse, even if they're not actually older than the woman.
Right.
So it's like it's things like that. Right. And I think it's kind of, it has some neat properties, because if you say a sentence between two people, no matter who says it, it conveys the same content. Yep. So for example, if I said to you, I went to the Presidio to meet you this morning.
Yeah.
It makes sense if I say it, but if you say it, it's conveying something. It's conveying different.
I mean, if I say the same sound,
say the exact same words, it's actually conveying something. Because you were already here.
Oh,
does that make?
Because it's a bad example. My home. Because I was here when you arrived.
Yeah, I need to come up with a more asymmetric example. So it's like, I drank oh, here's an example. I studied like Vietnamese this morning before meeting you this morning.
Yeah.
Okay, I say that implies like these things that happened in the world that I did.
Yeah.
But if you say it, that exact same words,
Yeah.
I studied Vietnamese before meeting you this morning, you're now saying you did it.
Right.
Whereas if I say it in English with like our names, I'd say like, Richard studied Vietnamese before meeting DK this morning.
Right.
If you repeated that sentence, it does mean the same thing.
Right.
The main point is that I've done such a bad job of explaining this. The main point is basically that the like pronouns, again, I'm like so new, I'm just learning, but the pronouns have that same property as proper nouns
Right.
in English because
they kind of get assigned and anchored into one of the
exactly.
parties.
So some of these things are fun.
Yeah.
I know all the like fun parts of learning a new language, like where adjectives and things go. But
Right.
in terms of how it informs your thinking, I would say no, I'm not there yet.
Right.
But I just it's fun seeing how like words are built up and it's indicative of kind of the history of like how concepts have been introduced and those kinds of things.
Right. And you mentioned that you kind of dove in head first. I forget exactly how you said it, but when you decided you wanted to figure this out, you just like started going. And that's a certain like approach to learning things. And I wonder if that is the same approach that you take kind of with everything in your life, or languages are, turned out to be a specific way that you want to approach. Like if you're trying to pick up a new language, a new computer programming language, do you do kind of the same thing? Obviously not Duolingo, but do you just like go in and write a hello world, or
it's an awesome question. I think there's a benefit between like oscillating on this approach of diving into start somewhere and then trying to step back and see as you start to understand what as you start to know what you don't know, or you're pretty clear on that uncomfortable feeling you get where you're just like, I don't think I'm getting it.
Yeah.
Is I then sort of start to try to internalize that and use that to find more I shouldn't say conventional, but like just see what other people have done to introduce or get into something. So in the concept of a programming language, definitely oscillate between the two. So I think it's really nice having an end goal to kind of pull you forward. Mm-hmm. It's like that goal is the thing that, in this case, like I want to be able to speak to my girlfriend's parents in Vietnamese, because it's just like a personal goal. So that's the kind of thing that like pulls me forward.
And how specific is that goal? Like, do you have an imagination that you're going to go travel there? They're going to visit
at some
here
point, and I can at least speak slow. Like, I'm not like, I don't have to be like crazy fluent.
Yeah.
But I want to be able to convey important things.
Right.
And hear and respond and be familial.
Yeah.
And so that's kind of this like end goal.
Mm-hmm.
And in terms of how it motivates the learning, like in this case, diving in a little bit, starting to recognize differences, then step back, then start to learn, okay, like what are like other courses available? What are other resources available?
Right.
To try to supplement directly where I'm lacking. And I do try to take the same approach with like libraries, if I'm like learning a new library or digging in, new programming languages. And again, I think it's usually just around recognizing that feeling of like, okay, something, if I'm not getting something, it's 99.99% of the time it's on me, like my framing is wrong, or I haven't recognized something that I need to, and kind of going into it. So but sometimes the challenge with these things is also finding a motivating enough goal to do that. It's I enjoy reading through like documentation around libraries and programming languages, because usually it's people, especially now, I feel like open source on all of these points is people write in a manner which is to try to generally kind of walk you through getting started, try to convey like the main points of what you get.
Right.
And in certain cases, you can resonate with that much more quickly. Like I've been learning Rust more recently. Again, just from, I don't have a particular project. Or I do actually. I wanted to just like step through the Rust implementations of a bunch of tokenizers that exist for, I think, OpenAI released theirs more recently. And prior to that, I was wanting to step through the tokenizer within Hugging Face. And I have more experience in C++, especially from kind of graduate school, and pre that, and so absolutely understand and resonate and have experienced the challenges of building up software in C++. And so as I'm like learning through Rust, I can more quickly understand the motivation. And also I'm just like really impressed by the primitives that people built up to really just totally avoid some of those kinds of things. So in that case of learning, it starts more from, reading books and, it could be blog posts, it could be tutorials, all of those things to kind of get a sense of getting the right kind of framing. But then eventually this stuff is, I think, only really tested by writing. I definitely believe that it's only when you actually get to write something do you really sort of check your concepts. And the same is true, I think, of writing about anything, but definitely agree with on the language point. Like I feel like I'm tested most on the Vietnamese side when I actually have to write it down. Like, did I actually remember the right accent? Did I actually remember the right letter of the alphabet? Is it the O or the O with the hat? And then, or, all these kinds of things. And the same is true, I think, language-wise. It's one thing to understand, what the borrow checker does in Rust. It's another to try to set up some novel project and then realize that, the way you do things in Python are not going to map one-to-one.
Right.
And so I think the main point, is like, I feel like I work best when I've got some kind of end goal that kind of really pulls me there, and then I oscillate between basically just trying to figure out how to get there.
But it sounds like in the case of Rust, the goal is maybe more to understand some documentation that piqued your interest, or kind of
I learned.
Actually, what if we zoom out a little bit? Because why Rust? Like everybody, it seems like Rust is having a moment, or maybe recent years it's had a moment that, to me, it reminds me a little bit of like Python 20 years ago, where like everybody who's really talented technically wants to get into it and learn it and loves it. But why is Rust having such a moment? What are the properties of it that make it so interesting?
So I think others could speak on this a lot better than I could, but knowing from my understanding at the moment of, so my motivation was to understand more deeply some parts of the stack that I use around like transformers and other parts of machine learning, when now people are writing more lower level code in Rust, as opposed to C or C++, or some intermediate language that might be transpiled, like Python. And so that was the motivation for me looking into this. And the properties of the language that I think there's a lot of properties, I guess, that require like praise, like the bindings, the ability to interoperate between Rust and Python. From what I've seen so far, seems to just be really, really, really nice, which is good. I've taken several stabs at going from Python to C and C++ on different occasions, and the reverse. And there's always challenges and things to think about, as you would expect. You need to think about like who's owning what memory, and if you're dropping into C, you're trying to do something performant, but you do have to think about allocations and basically who kind of gets to own what. But from what I've seen, those pieces in Rust are really solid. We're
usually using Rust like for a transformer project that may have a wrapper in Python, like it's a call out.
Exactly. So if you've like pip installed transformers from Hugging Face, I don't know whether it's brought in as a dependency or you do it separately, but pip install tokenizers is their other piece that's like needed for this, which is, so say you're doing some NLP project over strings. A part of it is turning the string into pieces where those pieces are mapped to elements in a vocabulary, which then themselves are given an embedding. This is kind of the first layer of how broadly like all of these language-based models to do things. This tokenizer piece, though, is like not like it's not that simple. Like it's not as simple as like, oh, you like take every letter or you just like split on white space. There's actually like a lot of nuance with how these things have been set up and evolved over time.
Is it because of like scoring like interrelationship between words or something?
Yeah, it's also it's also where equivalence between words can end up being captured too. So if you take again, this is where like, imagine you had the word jump and like jumping.
Mm-hmm.
It might be appropriate that they get represented by the same token, depending on your problem or the goals of your language model. And so the tokenizer is the part responsible, taking that and mapping it ultimately to the same integer or sets of integers.
Right.
That kind of, again, then map to some embeddings, which hopefully over time kind of, depending on kind of how you're fitting things and training things, kind of maintain these properties that you want. And so the main thing is, it's easier to step through parts of these libraries at the Python level just because the Python debugging in general is so straightforward. You can set breakpoints in places, print stuff out. You can patch places so that you can bring out more information to get more diagnostics. It's so flexible and fluid.
Mm-hmm.
But this part where it steps into the tokenizer is kind of like a black box from Python land. And so in general as well, I like to be able to isolate parts of the system just in their language entirely. So, run the tokenizer entirely from Rust and learn about what does debugging in Rust look like at the moment? Like, how does it work with GDB or, variants of their own? And these are not places where I've spent like a lot of time, especially within Rust. Yeah. And so that's kind of the fun thing. Also, types are really handy for working on a software project over time. Just the static typing is so helpful. And I think that's where Python over time you've seen like evolve. And that's where I think, again, Rust, the tooling around it from what I've used so far is also, I find to be really excellent. Again, you're talking to someone who's a novice, not like someone who's been learning for ages, but I use Emacs heavily, and the plugins that all go through the LSP, which I've forgotten what the acronym means, but basically is how the editor can query common tooling to get information about the language. It's excellent. So it does things like type inference. So if I'm hovering over a variable, or the editor actually just shows me in place what the type of this variable is. And this means that you've got this like nice, you're not necessarily having to write type annotations everywhere, right? But you've got this hinting all over the place that helps you out in terms of understanding exactly what you're doing, what methods you have available to you, and those kinds of things. And so to be honest, that kind of coding experience feels very similar to modern Python development, where if you're working with things like Pyrite, it'll give you abilities to prompt and see where you've done like type errors, etc. Except now, if I go through the effort of doing something well, I compile something and it's actually fast versus, in Python generally I'm penalized for every time I break apart a for loop for clarity. It's, I know in my heart that I've just made things a bit slower. So anyway, I think Rust is, a big draw from a systems point of view, like where you're not, this main point of the language is not garbage collected. So you're responsible for allocations of memory and freeing those things. And freeing those allocations. And so you have to think about ownership a lot more, and the benefit you get from that is, if you can decrease allocations and you're more thoughtful about how data is laid out in memory and how you access it, you get a massive performance improvement. And the thing that Rust does kind of really nicely is this concept of ownership, and it's very strict about it. And so it can actually avoid some of the problems that you have more commonly in C++, where you're passing around pointers to raw memory and it's not enforced at the language level who owns what. And so I think that is a big draw in terms of being able to write things. But so
and so it sounds like, you talked about sort of learning Vietnamese, and you have the goal of, be able to talk to your girlfriend's parents, and then Rust kind of drew you in because of sort of everything happening in Transformers and OpenAI APIs, stuff like that.
Yeah, I got drawn in, I would say, because I like learning. It's one thing to like download a model from online, run it, and be like, oh, that was cool. Yeah. But then as soon as you start trying to do something like understand, hey, if I try to run this over lots of documents, like what kind of variability can I expect on every level? Like variability performance wise, like how long does it take to run, but also variability statistically. It's like if I give a bunch of sentences, like how well does this run? And when you start seeing results that you don't like or something's off, I find it difficult to debug or build up hypotheses about what might be causing
I
that
see.
without having a deeper understanding of parts of the stack.
So it's almost like your learning experience of running different data sets through and seeing how they perform and where the edges are is what informs sort of your intuition around what could be done with it.
Exactly.
Okay.
And so I've been comfortable enough with not ever kind of running, say, like a tokenizer out of band.
Right.
But occasionally I've had to step in and I've like opened up the implementations of these tokenizers, and you see odd things occasionally where, or not odd things, but more just this subtleties. Like one version, so at Impira, we use this model called Layout LM for extracting information out of documents.
Mm-hmm.
The details of that isn't important for now, except between versions of Layout LM, they use slightly different tokenizers.
Mm-hmm.
And those tokenizers output slightly different information that actually then affects the embeddings that are kind of at this like first stage of processing a document.
Mm-hmm.
And it's pretty surprising to see some of these subtleties if you're not super familiar with what's going on in the tokenizer.
Right.
And to get familiar with the tokenizer, you have to
get Rust.
into Rust. Yeah. And so that's basically it. It was just
Right.
like, I don't have any kind of grand scheme yet, but I think again, like, I think it is neat seeing the appeal of this language and ecosystem over time. Like my expectation is as well that it's, and again, interoperability with other existing libraries can, in C++ especially, can be done well.
Right.
So my expectation is like the momentum continues, and there's always challenges, but it's just a bit of fun too.
Yeah.
I mean, I don't think it's hard to regret like learning something like that.
Yeah.
It just,
But it sounds like, so you mentioned that it's maybe related to your work at Impira. So is this, I'd assumed you were hacking on side projects and just trying to understand it better, but I didn't understand that it's so, is it pretty closely connected to stuff you're currently doing? Or?
Not so much, but the motivation, like I love working around these models, and especially transformers.
Mm-hmm.
And I find it really fun to try to get a sense of and just get a sense of why something works and what might be allowing it to work and what doesn't, purely so that as you take some of these models and you scale them up to different tasks that you might fine tune towards, or that could be work related or like a personal project related, having just more of an intuition, or at least building a sense of these things, really helps with the hypothesis generating part when you've got problems, basically.
Right.
When there's an output from your model that you don't like, and you're trying to understand where it's at. And so what really kind of, again, I would treat it almost like a learning piece. Like I want to learn over time how to train and utilize these systems in a variety of contexts, and understand their characteristics. Like where are they robust? Where are they not?
Yep.
What are characteristics of how they're trained that need to be maintained, or that that really show benefits? How do things change as things scale? All of this is useful information to inform then a technical understanding of when they can be maybe reliably deployed to have some product impact or not. And part of learning this is like trying experiments, but part of it, again, it's kind of like the language learning piece. It's also good to go back to like fundamentals and be like, okay, can I boil something down super simply and see what goes on?
Have you run into things so far in your exploration that have given you, I like to do this exercise a lot of times when I learn about a new product or technology, and I was actually suggesting to Jen, I said, let's just, whenever we see something, make 3 claims about headwinds and 3 claims about tailwinds.
Oh,
like,
interesting.
This is why this thing's never going to work. This is why it's obviously the future.
I like this. Yeah.
But I found that when doing it has like a bunch of properties, and that it helps you articulate what you're excited about, but it also makes sure that you're kind of steel manning the opposite side.
Yeah.
And then I think I've been intended to like write a piece or make a video about this, but I think if you do it, for a given, unknown in the world, if you publish it, then it engages people to say, no, you're totally wrong about number 2 on the tailwind. It's that's totally relevant, but here's what really matters, right? So it's a nice conversation starter and it doesn't make you too polarized, right?
Yeah.
So just at a high level framework, I was riffing while we were driving the other day. I was like, here's why Twitter's obviously going to win under the Elon Musk regime, and here's why like it has no chance, right? Kind of that sort of idea.
Yep.
And so I wonder sort of if we sort of zoom out and look at whatever level of zoom, is it transformers, is it large language models, is it the current OpenAI stuff? Like, are there things from your kind of deeper investigation in tokenizers that now would say like, oh my God, this is so obviously the future, or like, oh, this has no chance?
I would say like going deep on a tokenizer hasn't really informed that.
Okay.
It was like more a personal itch to scratch. And again, I think so much of like going deeper on something is usually informing a little like tactical issue. Yeah. And that allows you to make, forward progress with like hundreds or thousands of these. I think obviously the large language model stuff, I think is a really fun example to kind of go on the like headwinds and tailwinds piece.
Do you feel like you have, before we'll see if we can develop some real time here, right? But is your intuition more? Well, I don't know if I want you to reveal your.
Yeah, no, I'll maybe start with like the headwinds, which I think is cool. So, I think there's in no particular order, just like some stuff coming. So first of all, I think the ChatGPT and Copilot and GPT-3. So the first two being these products, and then GPT-3. When I say that, I mean like the API are all they're incredibly exciting and incredibly inspiring and useful in various forms.
Yeah.
I think the headwinds for them in this regard is that these are ultimately like big statistical models around language and tokens, etc. But especially the two products like ChatGPT and Copilot, this focus on generative problems, I think, is very smart.
Yeah.
Like machine learning has this problem, which is at the end of the day, you're coming up with some model which is not the same as the process of going from one variable to another.
Right.
And if you're going to have a mismatch at any point, then the output you get is going to be incorrect.
Right.
And that kind of prevents like the application of machine learning on like on a huge number of things, because it's not like a function that is well behaved that you can make like great guarantees at the level you'd want to make it. The smart thing about generative like products around generative AI is that they're integrating into a tight loop that already existed. I'm not asking a programmer to go and do more than they did before. Now I'm just giving them little points of guidance that when they're on point or useful are really time-saving and really exciting. And so I think that headwind around generative products the use in products where the generation of things is done, I think they have a ton of headwinds product-wise.
Headwinds meaning...
Oh, I'm sorry, tailwinds.
That's tailwinds. Okay.
Sorry, I said them the wrong way around.
Yeah.
I meant sorry.
Okay. So that's one of the reasons to be optimistic is that
totally.
The generative stuff it's really good at, and it can use statistics effectively to generate stuff that's interesting and creative. Exactly.
Yeah. And more importantly, if there's no huge downside to being wrong.
Right, yeah.
Like that's the big piece. You're not kicking someone out of a flow state they might have already been in. Like if someone wants to disable it, they can, but like someone had to do the task already. The same with
kind of augments or supplements.
Yes,
it doesn't
exactly.
Yeah.
Same with the generative AI around image.
Yeah. I've heard people make the claim the image stuff is even easier because you don't ever have anything really rooted in facts that can be wrong, whereas language, you could say something that's just, obviously false. Whereas language, like, well, I just decided to make 6 fingers on this instead of 5, and that was just part of my creativity.
Yeah, I think, it's funny seeing the like failure cases in each where something can look very plausible or sound very plausible, but not be grounded to reality in the way that is intended. So 6 fingers might be totally fine if you've got like some fantasy novel, but if you're trying to develop some depiction of someone that is supposed to be a reflection of reality, then it is a mistake.
Right. Yeah.
And I think that's the interesting thing about that I would say is like the asterisk next to the generative pieces, especially on the like ChatGPT side,
Mm-hmm.
is that you're unconstrained in the consumption of the output. Like I can go and generate something and I could forcibly try to make it bad
Right.
and then post it to the world. If I'm using Copilot, it can help me, but then I still got the type system of the language. I've still got my colleagues. I've still got code review. Like I've got a lot holding me to account. I have like actually what I'm trying to build in the product. And so I think that element. So these are all tailwinds, I think. I think the product tailwinds are really important for ultimately giving momentum for further work on this to improve it over time. Like I think that's a huge tailwind. I think it'd be much harder to like keep up conviction and investment around this if there weren't some of these kind of points in sight, especially on the content generation side around marketing. It's like there's this like one huge, I'm not saying there's only one, but I'm just saying this is a huge use case where already again people are having to write content and these systems can assist. I think is really powerful. So I'd say that's one big tailwind.
So the tailwind being that the generative stuff is already useful despite it being imperfect at everything we're imagining.
Exactly.
It already has utility and specific use cases.
And it hasn't needed to. It's not the case where to make use of these generative applications, you've had to like introduce a new person to do some new loop. It's like an engineer was already trying to write code. A marketer was already trying to put
that's a good point.
Content together. You're supplementing people who already existed. In their roles and
clearly like a little voice on your shoulder. Just
and that's commercially I think super important. I think the other kind of tailwind, research wise, or I say like not academic, but just like maybe we'll call it like an academic tailwind, is that. And again, this is where I'm just like I admire like a ton of the work like researchers and the folks at OpenAI had and the conviction they had around this, which is there's a huge kind of bucking of what used to be like classical machine learning with deep learning. So things like early stop. So when you optimize these big networks, you're kind of bouncing around with all these little approximations of gradients, slowly making all of the knobs or parameters like better. But there's all these, there's these kind of things you're supposed to do from, call it classical ML, that if you don't do, or you sort of just like skirt past, get you practically better results in deep learning.
What are those kinds of things?
Like things like early stopping, meaning when you're doing optimization, you stop before it converges on the training side. This is different than what you might do if you're fitting like a classical statistical model. And I say that, the big difference here is that these models are massive and they're operating in this regime with a lot of parameters and a lot of data. And the dynamics around how these models are fitted and how they generalize is different. And that's exciting from the perspective of it's kind of like a new regime. And, again, I say these things and someone might disagree and be like, oh no, like, people who've looked in sparse coding knew all about this like back in the day. And, but practically it's new, and it's great that we're able to like recast it and relearn how it fits to existing theory and understanding. But I think that is still also building a ton of momentum around it. And so that tailwind is big. It's because the hardware, there's been this, you start making things bigger, then you start realizing, oh, they benefit from different hardware. But then these things start reinforcing each other. It's like, hey, we make a big investment in hardware or GPUs in particular, or TPUs or an equivalent. And then you have like these geniuses who come up with like the transformer architecture, which is part of how the architecture is designed. It really benefits. It operates very well on a GPU. And so these things start self-reinforcing. So again, I treat these as tailwinds because it's, as progress is made forward about understanding these things and improving how they're optimized, understanding how they can be made more efficient, this all presents forward progress in some manner.
And in a sense, I might think of it as like a flywheel that has now been kickstarted. There's enough interest and momentum, and there's enough of a simple enough use case that it's getting more research behind it, more interest from practitioners, more hardware development, more capital allocated, et cetera.
Exactly. On all fronts, it could be at the level of research people are trying to do, where they understand like how these things might work. Like why do these systems have, why do things happen differently as like the data amount of data gets like really high?
Right.
What happens if we like look at really small examples? Like what do we know about a transformer? What happens if we try to like sparsify it and put on a CPU like some people are trying to do? Like the main point though is it's all, again, the flywheel is an excellent analogy. So I'd say again, that's a big tailwind for this.
Yep.
Again, just because it's going to give more opportunities for other little things to pull it forward.
Yep.
Goals to come up with 3.
Well, so yes, we've got flywheels as the recent one, and then I guess like the fact that they don't necessarily have, they can augment people's existing work is a really important one.
Yeah, there's like a product. I would say that there's the applicability on the product side and augmenting existing work.
Yep.
There's the flywheel, especially on the like research and development side, which I think is not to be snuffed at as well.
Yeah. And this, I mean, there's a lot within those and sub pieces. So we don't necessarily need to get to a full 3, but
cool. Those 2. And then on the headwind side, I think the main challenge. I mean, there are these. The main challenge, I think, from deploying it to like wider products and AI having like wider influence is that robustness and like understanding. And I'll try to like elaborate on those like points a little bit better, but those are, I think, necessary for it to have the same kind of like very high value applications at a high scale on certain things. So the applications we talked about so far, where it's like content generation, that's still matched to an individual. Same with software, it's still matched to an individual. The Copilot is useful because an individual's doing something.
Right.
But if I want to like process large amounts of information at a very large scale, that scales much more than an individual, where a model makes mistakes and how it makes those mistakes is like a full-on operations problem to sort out.
And is that's the robustness problem? Or that's,
Okay. And the hard part is not knowing how something can fail, or not having a means of understanding where it's failed and detecting it.
Right.
Makes it hard to operationalize.
Right. And when you say operationalize, I'm imagining what you might mean, but is it like a human feedback team that looks at various results or queries or attempts?
Yeah, imagine I make a product which is like, hey DK, I've made this like product where it helps like triage your email. And so I'm gonna make this up as I go. So if I get it wrong, I'll revisit the example. But like, it triages some stuff.
Yeah.
And on the happy path of this product, maybe it's great. You're like, oh, cool. I get a bunch of like, this, that, and these other things that I want to get rid of. And this can just do that. That's the happy path. But what about the unhappy path where it makes a mistake? So it takes something and deletes it, or it takes something and archives it, or didn't tell you that, I had reached out to you and to say I was going to be late or something like that.
Right.
Dealing with the unhappy path, now suddenly your interaction with email has changed. It previously used to be you go to your inbox, you like knew that you would have some stuff to sort out, but you had some systems around it. Now your approach and systems have to be very different. It's like, okay, I'm dealing with something that's a little bit random. Do I feel like, am I good about that? Does this mean I now have to review what it's put in archive? Right. Do I have to review the trash? So my point here is that if there's uncertainty or unpredictability at one step in the process, it ends up being passed down. And if I describe like the product I just described to you, that user experience isn't necessarily very good.
Right.
Because ultimately, me as the developer haven't done anything to deal with the ambiguity. I've just passed it on to you, the user.
I mean, it's kind of what spam folders are, right? It's like, did you check your spam folder?
Yeah. And we're lucky. I mean, that's funny because, Gmail hasn't taken it much further than that. It's like you've got the promotions and other things in the spam folder. Yeah. But I think it's probably because it's hard to have higher fidelity at the scale that they kind of operate on. But this is, the key point here is that when you've got you've got an amount of uncertainty and in a system that's hard to characterize, it means the end user of the system has to absorb it in some way in their process. you know, in this case I just described, you could be like, oh, that's cool. I'm going to hire this, you know, I'm going to hire a person to help me do this, or I will string together some other technology to like, you know, fix up the, you know, errors from Richard's system. But the reason I think this is a headwind is that you actually don't have the promise of applying this at scale if the operations around managing that uncertainty are prohibitive.
Right.
It's much easier to buy a product that does what it says it does, you know, as opposed to one that most of the time works. Like imagine if the camera just like turned off every few minutes. Like that makes this whole experience different,
right.
You know?
Yeah.
And so I think that's a headwind of on the product side of these things. And again, I think that's where you know, that's one of the challenges of like the ChatGPT flavor of things, is that people are, you know, where it can be used to write a large amount of content, where the implications for having wrong answers doesn't matter. No one feels this.
Is there any way, is there like an idea, there must already be, you know, floating around out there, but is there an idea for how to like route the result of a ChatGPT with some sort of published information on the web? Like, is that binding or mapping being considered, or is there like a few technology hypotheses around? I think there's
a lot of systems being thought about with regards to doing this kind of thing. So it's kind of like imagine you're generating content through some automated way.
Mm-hmm.
You might over time build up tests that again use equally complex or sophisticated technology, but they, you know, assert certain things about the content generated, so that you start to at least then have a feedback mechanism system where if the content generated is invalid in some way for your product or use case, you can like add that as a test case and then improve things going forward. Now, maybe if you end up with like too many test cases, they start to, you know,
create their own complexity.
They have their own complexity in terms of, you know, maybe they counteract one another, or maybe it turns out you need like, there's no good way to like push this upstream. And so you have to generate, you know, tens or hundreds of generations to find one that matches. But I think there's, you know, more sophisticated things around this in terms of like an exact thing where someone's like, hey, I've got our generation grounded in external knowledge. I think that's where some of these search engines are maybe operating, but what they're trying to do there is...
Are there examples that come to mind?
The two that come to mind, I think it's called Perplexity and you.com. And I'm totally just like an observer.
Yeah,
so people who are much closer know more.
No,
from what I understand,
most people probably don't have a lot of depth. I think you're
I think everyone's figuring it out.
Beginner.
No,
so.
yeah, everyone's trying. So from what I understand at the moment, the question you ask is like, is there a way to like check that it's been grounded? One approach that I think is part of these systems, again, this could be completely wrong, so take with a huge grain of salt, but is to actually try to have the system output references, or so essentially, you know, make it cite what it's done. But again, I know there are people looking at.
So would that be like something like a ChatGPT interface, and I would say, when is Valentine's Day? And then it would say Valentine's Day is February 14th, and it would have a link to a website where it pulled that information from. Yeah. But like a single place. Because my understanding is a lot of the way the language models work, they are often using a statistical aggregation from a lot of different sources. And so is it just like this is the primary source, or this one was the most contributing to the score?
This is a really good question, and just I'm stepping way outside of an area with like direct familiarity.
Perfect,
but if you took a language model and trained it to a language model at the end of the day is some model to like predict an X token or some variant of this kind of task. From my understanding of like, if you just took this language model in that way and you treated this like a completion problem, if you said like, when is Valentine's Day, you're more relying on an utterance of Valentine's Day and a link somewhere from your training set than you are from the system, taking a document that was at, abc.xyz that mentioned Valentine's Day and sort of building that reference. But again, I think this depends massively on how it's trained and set up. But
it seems like so much of the models that I've observed so far, it feels like it's really predicting the next word versus having any sense of what it's talking about. Is that fair, or is that too harsh on it?
I suspect it's somewhere in between, but I think everyone's trying to figure this out. Like,
Okay.
I mean, at the end of the day, the generation process of a sequence, there's quite a few algorithms to do that. The most naive one is greedy, where you do just generate the next token and take the most probable.
Right.
And, you know, you could imagine if a system is, if it's aligned so that, you know, you ask it to like provide a citation and it sees this and completes it accordingly, you know, at some point it says, oh, the next token is H, then T, P,
right.
colon, / you know, www dot. And then at this point, maybe there are some completions that are more likely than others.
Right.
And again, that's just been because, you know, that next token conditioned on everything seen so far kind of informs it to one web address or another. Now, does it like know that web address, you know, is exactly the thing to use for this fact? Like,
right.
The sense of no, I don't think so. But again, it's, yeah, I mean, this is the kind of magic, I think, of ChatGPT, is that even if you've been like a huge skeptic previously, or you are still a big skeptic, it's, I think the interactivity and more than just parroting, I think, is still like pretty undeniable from the product side. So,
right.
You know, to your actual point, like, I guess I can't answer the like philosophical point,
right.
but in terms of it, mechanistically, I know it's just producing those things, but yeah.
And it isn't that really what we're doing? Like when you're learning Vietnamese, or we learned English originally, like,
so yeah, this is an interesting, I heard this point a lot where it's like, well, at the end of the day, aren't we just like a big language model? And I think that kind of misses the point a little bit. So at some level, you could model us as taking some input and producing some output. And language, I think, is, you know, language is interesting because it's us trying to convey information about the world, or intents about future things, or, you know, describing future states,
right,
or the past, etc. And I'm not going to phrase this well because it's not something I've like tried to articulate well before, but if you're trying to understand a system from the outside, it's like you take in some input and get some output. You make like so you could take like GPT, like the latest GPT. It's like super impressive. You give it some thing in and it produces some output, and we say, oh wow, that looks super impressive. Why do we say it looks super impressive? Well, the like surface level characteristics of the language are all like a tick, you know, it like grammatically makes sense. It sounds coherent. It's like referencing stuff I asked in the question. This is all good. If you look at like older GPTs or the smaller models that, you know, even are available today on OpenAI.
Like 1 and 2 or even before that?
I don't know how these relate exactly to the generations of GPT versus just like the size of the models now, but they have them like DaVinci is the latest, you know, DaVinci is the big one you use, Curie and Babbage, and then I think Ada as well. And so you can kind of go down. But the point is that as you use those other models from the outside, they're still a language model, but they don't look as good. Well, what do we mean by not as good? Well, they start to suffer on the like surface level things. So some, you know, surface level parts of the language look incorrect, like a word's missed, or something doesn't seem coherent with the question, or the question wasn't actually answered. I think like when you get to the level of like the confident bullshitter, which is like, you know, that's too harsh, I think, but like the GPT piece, it's like, oh, it looks good. You start asking, I think, stronger questions about the quality of the model. So imagine I have a GPT model again to do your email thing, and I'm going to apply it like at a larger scale. So this like turn up the like importance of it. Let's imagine it's going to reply to emails for you. So you've gotten to the point now of like, okay, the model can like write coherent sentences. It sounds like me. But what might you still have misgivings about? Or like, what are the necessary things of that model for you to actually deploy it? Well, these questions are harder to answer. It's like, does this model reason the same way about the consequence of something to me? Does it actually reason about the, you know, contents of like a request someone makes to me and the concept of like what I'm trying to do, you know? These are hard questions to assess the model on. And so coming right back again to that question of like, are we just like a big language model? Yes, we take in input and produce output, but I think the output is causally related to how we think about the world and the actions on it. Whereas that is not the case necessarily in a language model. You can get causal relationships, and you can, like in a language model, you can do things like, oh, let's change a bunch of words and see if that changes the output. If it doesn't, then you might say, hey, that intervention we made where we changed these words, seems like, those words are not causally related to the output.
Right.
So you can make causal statements or hypotheses at the level of the words, but not higher. So does that make sense? I guess at the end of the day, like, I think language is, I don't think this is too controversial. It's like language is causally related to
something else, a world model that we're, like, if we take a simple human world model, we might think about, optimizing to kind of aggregate more energy or something, right? I don't know, like we're trying to eat things and I don't know.
Simple. They can be more personal too. It's like, you're trying to, maybe you as someone who deals with email, you try to, you're always polite. You're a nice person because you want to do good in the world.
Right.
Then that colors how you interact with people, even if like someone was rude to you. But my point being is that you've got intention out, like there's intentions, goals that drive you that are harder to articulate.
But it feels like they would mostly, like almost all of those kinds of things, at least in my mind, seem to be like, am I safe? Am I loved? Kind of. Will I be able to, survive, another day? Like ultimately that feels kind of like
at the highest level,
everything kind of boils down to.
Boils down
and
to
probably there's no GPT that cares if it's loved or safe or going to live tomorrow, or like those are just not concepts that they.
Yeah, imagine. It's interesting to even going down from those like loftier things. Like imagine a system responsible for replying to your email, and you've got two people who want to meet with you at the same time.
Right.
That you realize now, like formulating the correct response is not just conditioned on one email.
Right.
Because they can't be answered in isolation. If you say yes to both.
Yeah.
Or so I shouldn't say they can't be. You don't want them to be. Your personal...
There's a different goal in mind.
Yeah, you don't want to have a conflict.
There's trade-offs.
Like that's a state you want to avoid. And that is nothing to do with the language in one email.
Right.
That's, you need the language in both, and a concept that these two can conflict in some manner.
But I think you also need to know how you, like, there might be aspects of meeting one that you appreciate more or value more.
Right. And
there might be aspects of meeting two that you appreciate more. It's not that they even necessarily have their own, like it's, I guess if I had that situation, I have to evaluate, is email one, going to have a near-term payoff versus email two. And I'm saying in terms of being loved and safe and, have enough food or whatever. And those things, even I, looking at those emails, end up just kind of having to make a judgment call based on like my perception of like, oh, I have a close relationship with that one and it's going to be a near-term payoff, but I really want to go for the longer-term payoff here. And I have like a longer-term relationship. And I think whatever the sets of things, I probably couldn't even, I'd really have to dig to be able to state it myself. But my point is, I think none of that exists in the machine agent that would be trying to accomplish this with similar language techniques.
Right. The hard part is even communicating that intent. Yeah. So,
we almost don't even know how to describe it about ourselves, right?
Yeah. And these are complex. Imagine this is, machine learning models that are doing more simple things like classifying an image, like does it have a bottle in it or not? That example, like getting that example together and having anybody able to interpret that's correct, yes, the image has a bottle in it or no, it doesn't, is pretty straightforward. So it's more straightforward to get lots of those examples.
Right.
But to, take the example you just gave where you've got these like two emails and then you want to try to give a preference of response to both. That's like a more complex, nuanced example to get together. And so pulling those things and it's also dependent on the person and these other factors,
right,
which would be very difficult to infer just from the example alone. And so I think, that I would put this as like a headwind, which is that, again, kind of coming back to that, is ultimately that the interface, the interface of these language models is so general. Like input is a string, output is a string. That doesn't mean that type checks for every single product problem. Just because you can, shoehorn it in, doesn't mean it's going to be effective at larger scales, especially. And, I think the way this could manifest as like a super strong headwind is just, a little bit of burnout from the perspective of people trying to use it,
Right. So you can use it for the generative, kind of vertical specific generative tasks, like maybe writing marketing copy or helping code gen to augment your creative work. But it may be a long time before we get a lot further. And if it takes too long, it burns out. It's almost like the opposite of your flywheel point.
Yeah, it's the flywheel in the opposite direction.
Yeah, like
but again, this is the what is this process called? Steelmanning, where you take both sides. So anyway,
it was. Yeah, I mean, I would like. There's probably some actual belief you have, and maybe you actually believe both sides to some extent.
I think both can be true.
Yeah,
like I truly think that the avenues on the generative side, there'll be more and more applications of that because there are a lot of processes where people are having to do things where they bring information to the table and communicating it or putting it into some existing architecture is the challenge, whether that's like marketing copy where you're communicating or, a software engineer where you're trying to bring something new and add something to some product, but there's like some aspects that are to call it like more rote that you might be doing.
Right.
I don't like, just at a like philosophical level, I don't like the use of Copilot. When people tell me they use it to write their tests, I was like, that's super interesting. Like tests are the place you like really want to do like most of the thinking. But that's beside the point. So I think the headwind is just the fact that there'll be a lot of other applications I think people will try that will really struggle to like scale because of the fact that those applications don't have this existing feedback loop that generative stuff has. And the very worst case would be like, burnout from it.
Right. Right. And you've been kind of in the, academic and industry side of this for, I mean, how long? A decade?
Yeah, it's just over a decade now. Yeah.
And so is the kind of stuff we're seeing today what the kinds of dreams that originally drew you in, or sort of where are we on your sort of journey of excitement?
Yeah, that's a good question. I mean, some things today I think are just incredible. Like there's a lot that I think is incredible today versus 10 years ago.
Yeah.
A problem I worked on like during my PhD, for example, is unrelated to language or like most common vision problems, but is recovering structures from 2D and 3D image data. So how do you recover like a three-dimensional representation of some object or object class you care about? And
just from like a single image of it, or
in some cases, yeah. So I worked on a problem that was someone else had sort of shown it to be true beforehand, and it was this problem. The way they solved. So the problem was, it's so contrived but kind of fun. It's, imagine I have like 30 pictures of dolphins, different dolphins from different views. The question is like, can I learn from that a model that sort of represents its shape and how the dolphin moves?
So you've got 30 different dolphins, 30 different perspectives, 30 different 2D images.
2D images, yeah. So in every case, you're missing 3D. And so
and you're trying to generalize what a dolphin is from that.
Yes, yeah. Now, there's a huge asterisk here, which is the way this was done still had a like parametric model for the shape of the dolphin and a prior as to how it could deform. I mean, so what
prior as to how it
I'll
could
explain
deform.
what I mean by this. So you've got, like, just to be concrete about it, you have like a mesh of, which is a bunch of vertices where there's they are adjacent to other vertices, so they connect to one another, and this mesh defines a surface of a dolphin. So if I give you the mesh, it looks like me giving you the 3D coordinates of all these nodes.
Right.
And that
just a bunch of XYZs.
Yes, exactly. And that
space,
in some coordinate system, and that defines some 3D surface, which I can then render and show you as a pretty picture. You're like, wow, that looks like a 3D model of a dolphin.
You have that mesh already as a concept defined?
Yes, exactly.
Independent of the 30 pictures of the dolphin.
Independent of the 30 pictures. Okay. So I may have it defined. So I have it defined. And the other, but there might be a lot of vertices.
Mm-hmm.
And the
you'd hope there would be, right?
Yes.
Because you want as deep resolution as possible.
Exactly.
Yeah.
You don't, just to be super clear though, to get like, the Pixar smooth, people and animals you see, that doesn't necessarily mean you have to have like vertices at that level. The smoothness of what you see rendered comes from the definition of what's called the surface model, which is dependent on those vertices. So coarse vertices can still define a smooth surface.
So the vertices are defining the structure, and then maybe a smooth or a hairy animal in a Pixar thing is defined by some other surface property, like almost like an image map of
I think it's definitely more complex for hair and stuff like that, but just describing just the smooth part, especially where I was most familiar with. The key point I just wanted to convey is that you've got a large number of vertices to try to describe the surface.
Mm-hmm. But the vertices are not describing the texture as much as they're describing like the shape.
Just the shape, yeah.
Okay.
And so now a question is like, imagine I ask you, hey, let's try to make this dolphin bend. Like, let's make it as if it had jumped out of the water.
Mm-hmm. How would flexing a muscle?
Exactly.
Or something?
How would you do that? Well, you go, well, that's pretty tricky. I have to like move all these vertices individually. Because again, I've got these vertices.
Yep.
If you go and move one, it just looks weird. It would be like me pulling like a chunk of my head out. And so you've got this problem, which is you've got this representation of the animal,
right?
But you don't have easy ways of deforming it,
right? Where
the deformations are still realistic and actually represent what you want to represent,
right?
And so the way this project was, or this problem was formulated was, you have this original mesh and vertices. You have ways of deforming it, what was called just a linear shape model, where basically you just add some unknown amount to like every vertex, and you have a bunch of these additions you can make.
You're just creating noise.
It's not you're going to figure the actual machine learning problem is to figure out what those things should look like.
Which vertices you want to deform in which ways?
Yes, exactly, and how they should deform together. So basically, if I'm going to make some small deformation, how should like vertex 1 move? Like how much should it move versus vertex 2, 3, etc. And so the idea, I'm taking a longer time than I wanted to explain this, but basically no, it's good. I appreciate it. It's more a reflection of my description. So the problem ended up being if you're looking at a single picture, you say, okay, I'm going to pretend this is my dolphin. It's had some deformation applied to it, which is unknown. And then I'm looking at this dolphin from some unknown camera angle,
right? Which
is also an unknown.
Yeah.
And then I'm going to try and match up the silhouettes. And so you end up doing this big optimization problem, just to kind of talk through it and why I'm kind of comparing this of sort of then and now. So I worked a lot on how to do this and then how to do this more efficiently. And there are a lot of other people kind of where I was working at Oxford and when I was at Microsoft Research through the like periods I was there. And this was super neat. Now, the key part of this was this deformation model and geometry I talked about, like, hey, you had to come up with this like dolphin. Yep. And this was really important because this is what kind of constrains the solution. Like the system is trying to find a model that satisfies all of these images together, but it's still very much constrained, purposely so, by that those vertices and their topology that I mentioned. That's what I meant by the prior. That topology and the way we allow it to deform is our prior that we kind of impose. And that's super important for actually having a high quality result. Now, like 10 years onwards, there's so much more work around having that prior be informed by data. It's like, hey, let's like take a ton of images and a ton of models already and have that inform kind of where we start. And
so in your PhD, you were doing 30 2D images. Now you might crawl the web and pull in every dolphin image you could find? Or?
Yeah, so from my understanding of like where points have advanced on this is basically you just move away from so there's advantages and disadvantages to putting a lot of human energy into that model I just described. If I have some downstream system I'm trying to put this into, where I have to know ahead of time, like the number of vertices, or the vertices have like semantics in that downstream system. Like I'm going to put my dolphin into a game,
Right?
and my game has a mapping already from these vertices to some control system or something like that. Then it's good that I've specified this, but it's pretty hard to still do. Now, those kinds of things, those priors can just be learned more outright from images. And so you still might do the problem of, hey, let's try to fit a dolphin to 30 pictures, but you haven't like handcrafted the dolphin to start with.
Right.
So I think on the deep learning side is like all the kind of impressive part of this, where you basically come up with these like just very complex functions to describe these things. But it's been pretty lucrative and pretty amazing. I think the other thing, kind of 10 years ago, where and when I did my PhD definitely informed like my own kind of bias towards my like initial preferences in machine learning. I loved and love like Bayesian methods for expressing what you're doing. So this is where you're trying to describe a mathematical model that might describe how you go from one variable to what you observe. And then all of the challenge, or a huge part of the challenge, I should say, is assuming your model is okay, is going in reverse. How do you actually do inference? But the really kind of magical part about when you do Bayesian inference fully, like go full Bayes, is that you capture uncertainty very naturally. So if if the data you observe is not telling you enough, you'll get uncertainty automatically from the distribution that you do.
And your goal is you want to generate that uncertainty so you can maybe correct it, or?
Again, yeah, exactly, because it's going to inform something downstream. Like if I'm trying to estimate some quantity, but I have some measure of uncertainty around it, it could be like the parameters for a distribution that describes it, or it could be like a more coarse level statistic that can oftentimes be more helpful or might be necessary, again, given the application. It all depends on what you're doing downstream. I think that's the kind of moral of the story of all of this. It totally depends on what the consumer needs from it.
I see.
And so I loved and fell in love with a ton of that stuff.
Yeah.
And there are some really kind of neat applications of it. Like I remember at Microsoft Research, they had done, and they do so much like amazing stuff around all of this. But the part at the time that was really neat was, I think, how they matched. It's called Trueskill. It's a system for matching players on like Xbox Live.
Oh yeah, yeah.
And it's a tricky problem because basically you're trying to evaluate the skill of someone quite quickly, and it has real product impact. But understanding this all relates a lot to these other kind of problems of like, I mean, DK's just signed up for playing some game, and he's we're going to drop him into. We've got to pick like which match we put him in, and you've got this delicate balance of like, do we put him in a match where we like learn a ton about him, or do we put him in a match where it's kind of safe for him so he doesn't get completely slaughtered or whatever. But
is it kind of an explore exploit trade-off?
Yes, exactly. Okay. But again, that uncertainty can be really helpful in terms of the uncertainty you have about someone's estimation of skill, and then using for ranking can again inform and help that.
Is it typically that kind of matching on an Xbox game? Would it be a game that is fairly constrained in like a one player versus player opponent kind of situation, or like
I think it still was used for like team-based activities too.
Like I'm imagining like Halo open world, I don't
So again, I haven't been playing games seriously since for more than 2 decades now, or maybe that's a little bit much, maybe a decade and a bit. But from my understanding, it was utilized to various degrees throughout. Both like one-on-one is like the most straightforward setting, kind of like it's like a game of chess. But I think it can still be very much informative towards Halo type games where it's like team versus team.
Did you look at, I think in chess they have those ELO scores?
Yep, ELO. Yeah, they actually, they
thing?
compare, I think in the Trueskill paper, if I remember, or it's been a long time since I read this, or the related material, but they do a comparison against ELO. I don't know the details of ELO, but in terms of how it's constructed and the adjustments made, basically they compare I think how quickly from memory how quickly the Trueskill algorithm converges to the Trueskill versus like the ELO algorithm.
Oh, I see.
Because
so
again,
ELO is almost like a benchmark that's used to figure out if Trueskill
exactly
is
it's used
performing
as
better or faster.
Exactly. Again, it would be like, imagine secretly I was a grandmaster at chess. I'm not. I suck.
Yeah, yeah.
I don't play. But imagine I'm a grandmaster and no one knows like where I'm at.
Yeah.
A good experience for me would be discovering that skill quickly enough so I can then play against someone at my level so that I enjoy it. Similarly, on the reverse side, if I was just a total noob.
Yeah.
And so that's where, convergence of getting tight bounds on my like absolute skill is really useful for providing me the best experience.
Do you solicit in Trueskill? Do you take kind of surveyed input as valid or?
I'm from memory. I think it was based on outcome of the.
So you have to at least play one. It's like you go in with no data. And
you can go in. What is neat about some of these, what I fell in love with about some of these methods and applications, especially, was you actually could come to it with a prior. Here's the like distribution of whether like it's probably unlikely I'm a grandmaster. If I was just picking, and it's like how do you?
A random person in the world is
exactly
not a grandmaster. So.
Exactly, and so that's. What's neat is that you can encode that. Again, it totally depends on how it's set up and whether inference is tractable. Mm-hmm. But that was what was appealing to me, is that those prior beliefs could be brought to bear, and the models, when effective, could also deviate from those priors quickly as well if the data back there too. So the probability that I'm a grandmaster coming in, like looking at some population or conditioned on some other things known about me, is still probably really low. It's like always low, because being a grandmaster is very hard and very rare. But how I play can then inform these systems more quickly to adjust.
So is there like, it sounds like the speed of convergence on the truth is is that one of the main optimizations, is trying to get it as quickly as possible?
The fun part about this probabilistic modeling was you operated at the level of trying to describe distributions and how one distribution was kind of how one variable was the function of other variables, and then how it impacted its distribution. But you're talking all about distributions. You're like, okay, and so when you then you've got some mapping to. You've ultimately got some mapping to what you observe, which is like the outcome of, say, two players playing a game together. And you're trying to take that outcome and inform from it what your actual skill is. Like if two players played one another. What's really cool about Bayesian inference or Bayesian like methods is that you're focusing at this modeling layer. And then when you need to do certain types of inference, that's conceptually turning the crank. It's like you take the distribution and you're like, okay, now I need to find like the posterior distribution. Or if I want to try to find the maximum value, like the most probable value in the posterior, that's like a certain type of optimization problem I might do. And then when you've got your optimization problem, you go, okay, cool, now it's this flavor of optimization problem. I'm going to deploy these optimization algorithms against it, gradient descent, or a Newton method, meaning like taking into account second derivatives or some approximation thereof. But it was fun from a modeling and engineering perspective, because you deal at this level of modeling. Then the next part, where it's like going from model to optimization problem and then optimization problem to algorithm, you were able to kind of work off the shoulders of giants. And it was pretty fun when you're like, oh, wow, like this problem I'm trying to solve actually looks like this common optimization problem. And there's a bunch of other techniques and literature I can deploy against it.
Right.
That was very fun.
So you're kind of working with a bunch of building blocks that are already well understood and assembling them in a novel way to accomplish something new.
Exactly. The challenge comes when you make like a small modeling change, which seems perceptibly small, but then changes the flavor of the optimization problem drastically. It could change it from being solvable in polynomial time to solvable in like exponential time. And that's just tough. That's just life. You're like, oh, okay, wow, I have this modeling interaction. Like these variables should interact in some way or another.
So you have to have enough depth at each of what the building blocks
you still need
is doing, because otherwise you might tune it in a way that it wasn't really designed for.
Exactly. It's like you go to do the optimization problem and you realize that, what I worked on with these like surfaces, for example, a lot of the time was spent at the optimization problem level, and then how to make the optimizer efficient enough. Just kind of to give more context on how like say like image classification works with deep learning,
Mm-hmm.
there's almost no operation at the like probabilistic modeling level. I say everyone, this is too general, but like when you see this written down, someone will say, here's the loss function. They've just straight to the optimization problem. Like this is what we want to optimize.
Mm-hmm.
They choose some measure of error. And then there's been a ton of work on the actual doing the optimizer, like stochastic gradient descent, and then all of the variations on top of it that make use of properties of the problem and models to try to converge and do things more quickly. But a ton of the focus is on that area. And so why does any of this matter? Like coming back to it, on going full Bayes is fun because when you get an output, you have a distribution as your output, and it's just very satisfying to have that point of uncertainty because for downstream things it can be very informative. So that was what made me kind of fall in love with things. And then from that, again, I was just like, I think quite lucky at the time at Oxford. I had some fun interactions with different people where I got exposed to things like probabilistic programming, where you can try to write again a model. The term generative model has been has changed a little bit in like common terminology today. When I say generative model, I think you probably think of like, like Stable Diffusion or ChatGPT, but more generically, it just means like a way of generating what you observe.
Right.
And probabilistic programming is a neat way of being able to describe like, hey, how you think your data might have been generated. And then again, having the system automatically go through those steps I talked about around the optimization algorithm and then actually doing it.
Right.
So all of that stuff I think was like very enticing to me, and it's still very relevant and still has a ton of amazing research being done on it today. I think I came later to the game with deep learning because the reality is deep learning kind of settles on in certain problems like, hey, this is the optimization problem. My statements are sounding way too like
more
cut and dry as well.
maybe
They're not. Yeah. Nor do I even think that.
Sure.
But the challenges with deep learning actually basically says, hey, we're not even going to try to write down our generative assumptions. We are going to make assumptions about how we think the process should work in reverse. So for example, if I'm like trying to classify whether an image has my cup in it, I might make the architecture choice that I use convolutions. And I make that architecture choice as an engineering trade-off. I go, okay, by sharing these weights across each position, I improve the amount of data that's going to impact those weights because they have to be applicable at each position. And I'm okay with that from the perspective of my response should be covariant with translation. And so that's an engineering trade-off you make. You make this architecture change to
because you know specifically about this cup glass problem you're trying to solve.
That's exactly it. Yeah. And so I was that just didn't capture my like interest when it was kind of first coming out, but it was incredible over time in terms of what has been able to be shown with this kind of work and scaling these things up further and further. And I would say the other important part that I'm impressed by 10 years later is just the level of like open source and contribution and just how fast and really available it is to do things now. I think it's incredible. Like when I was doing and finishing up my PhD, this was pre-TensorFlow and pre-PyTorch. There were other tools in place for doing the kinds of styles of computation that these toolkits allow, which a large part of it is basically you describing some process and it being able to help you calculate gradients to then kind of do optimization. So there's called Tiano at the time was one I was like most familiar with. But just the level of like ergonomics and resources and performance of these systems now is so crazy. And just I love the attitude and ethos that's building more and more around this as well. Like I love the fact that people share code now when they publish their paper. I think it's phenomenal. I think hopefully over time there's more sharing of data. I think it's a ludicrous expectation to imagine a big company releasing their data set. Because that's kind of their competitive advantage. Like at the end of the day, they're trying to make money in some form or other or have that advantage. But I think that's where the value of, that's where when these investments and benchmarks are made, and they have to keep being made because benchmarks get beaten, and then
Right.
they have to keep moving forward. But I think that's also super exciting. So I love that aspect. I think
I think it's an interesting point that, I mean, I also love open source, and I'm just like, I was even just like this week, I was just like reveling in how amazing some stuff that I'm, sort of, playing with is getting built so fast because it's, everything's open source. But I wonder sort of if we were to take a look at all of the generative stuff, and then we sort of think about, OpenAI is named OpenAI, but then you exit via an API, and probably all of the compute resources and all the team behind that is way too, it requires too much to be kind of fully open source, right? Like it needs to assemble and control a bit more than maybe developing Linux operating system or something, right? But then I think Stable Diffusion, Stability AI came out and at least picked off one piece of what OpenAI was doing and showed a more open way to do it, right? And my understanding is that's much simpler of a problem in the image space than the large language model space. But is there a trend or a force that's going to make more of this actually open from a kind of data perspective? And I mean, all the A100s and all the compute resources required, there's real cost to that, and that's a lot of what provides the advantage. So like, will OpenAI become more open? Will Stability AI have an interesting large language model? Will Anthropic or Cohere or any of the other kind of LLMs, will we get to a more open world, or is AI ultimately a more closed centralizing function?
Pontification about the future is always fun. I guess my
you don't have to be right.
No,
exactly.
what your thoughts are. So I think it's useful to always like consider what drives something to be open source. Mm-hmm. And there's a lot of positives for companies to do it business wise, and there's a lot of costs to do it. It's there's like a clear trade-off.
Yeah.
In some cases you give up competitive advantage. Now that this is like all of those things I say are worth like revisiting. So it's like you give up competitive advantage. Well, maybe a certain modeling technique or something special about your code is not that important. That's why it's fine to open up. The other benefit though is to your consumer. Like maybe they're going to be more likely to buy what you're building if they can see what's under the hood, or make adjustments on top of it, or they have there's some strategy so that if you go out of business or there's something you can't address on your roadmap quickly enough for them, they're able to address instead. These are varieties of, and there's also the from the perspective of being able to, it's useful for recruiting. Like if you have an awesome product and a really neat code base and people getting involved in it who become passionate about your project, those are amazing people to kind of bring on board. So again, there's just like, there's so many advantages and so many disadvantages. Sorry. And there's a lot of disadvantages that could be very material and impacting a company in different ways. And so I think when it comes to models and the data behind them, with the modeling side, I think it's interesting that companies have been releasing models. And I think people are pretty unfair to Google on these things. Google releases a lot of models. They keep a lot of models too that they don't release, but like T5 Flan or Flan T5, whichever ordering you like, is really useful. Like it's really useful to
I haven't seen that. What is Flan T5?
So T5 is their language model. And then the Flan one is where it's been like fine-tuned for, I think it was an instruction-based fine-tuning.
So this is the equivalent of like a GPT instruct, but Google's
yes,
version
from my
of it?
understanding. But the neat part about it is it's there and it's a very practical starting point. And again, they've released like different sizes of it, so practically you can, take it on board and do things with it.
So you like run it on your own machine?
Yes.
Or?
Yeah.
Okay, cool.
And so that's an example where I think someone's been open with the model, but not the data behind it.
Right.
Used to do it.
Like how it was trained is closed. And so if you wanted to train it in a different direction, you still need to go back to the original data source, which is not
Exactly.
available.
Yeah. And I think the question will be is, like, over time is, will there be things that necessitate exposure of that training process or the data behind it?
Mm-hmm.
So would those forces be like, maybe it comes to a point where users just don't want to use a model. Like maybe it becomes impossible for a user to use a model reliably
Mm-hmm.
without certain conditions about the data set being met. Maybe there's some problems that necessitate that. So,
Right.
but I think it'll be like something has to push to open up
Right.
open that up like one step further. Like companies occasionally release bits of training code. So for example, like AlphaZero, they released like the stub of the code from memory that I looked through. So it was like the general framework, but they had a lot of like areas stubbed out. I only bring that up as an example of more just like, people do let you, various projects, they let you peek under the hood a little bit more. But I think it boils down to where it kind of makes sense for it to commercially happen. I think on the side of like language modeling, there are lots of large open source data sets that are used for language models as starting points. But I think all of the data sets that OpenAI and this ilk collect to assist in improving the language model, all of the reinforcement learning with human feedback data that was acquired to then build the reward model that makes the model better. Like theoretically it could be open, but it's like they spend a lot of money making that data.
The human feedback part, they're hiring people to do that, right?
Right,
Click
exactly.
on things, make decisions. Those are not
so
cheap.
It's really tricky to be like, hey, like, are they actually incentivized to do that? And so, and again, if the API is sufficient where people are not going to like push them on this, then I wouldn't expect it to happen. So I guess to actually like summarize my argument like more succinctly would be like, I think there has to be either you have a force like stability where they come in with money and just decide to like blow it wide open with the data sets and the models that they provide to open things up. But again, like it kind of over time has to commercially make sense.
Yeah. What is do you think everybody has a similar view of what the commercial application is? Like, is this all ultimately trying to solve search in a new way, or is this more of an open-ended, like what is the commercial thing? I mean, AGI is just going to come and solve everything.
I don't know. I mean, it'll.
Who knows?
That all sounds. Yeah. I mean, I think I think that all sounds neat to some varying degree. I sort of like. I like thinking, and from every perspective, like thinking about what I want to do, what I learn, and having some actions in the world. And maybe the end goal of all of this is to take the stuff you don't want to do and have something else does it where it seems like it has low cost to being done in some way. Like I'm not just having a person do some menial task, or I'm having to like treat them badly to do it, or they're getting unfairly paid, or etc.
Right.
I think there needs to be like middle grounds though before this. Like this is like this huge idea that's too lofty to go after. In terms of what the end goal at the intermediate point might look like, I think ChatGPT has reopened up the conversation around what it would be, this idea of which is like not that, it's not new product wise, but it's like a reinvention of things 20 years ago, where it's like your portal to the web is not an index like Google to websites. It's just to get the answer you want.
Right. Yeah.
And it continues the trend that Google's also been on, which is to try to provide you the answer before you even navigate to the pages.
Yeah. And the one box, has been that forever.
Yeah, exactly. I mean, that's the key piece of the UI that is just staying exactly the same.
Yeah.
So I think the large language models has definitely reopened up that conversation of like, wow, this is super magical. If you can ask a question and follow it up, like there's the chat piece of ChatGPT is so cool, and it's just fun. Like
it's almost like the big innovation in the UX almost seems to be the query by query attention window. Like meaning in traditional web search, I type in a query, I look at the 10 links, and I'm like, I get why it gave me the thing that I don't want. So I'm going to add an extra keyword to try to narrow and focus it on what I actually mean. But from one query to the next, it has no probably real recollection or input. Whereas the transformers and attention windows and ChatGPT, I think is kind of, keeping some of the state.
Yeah, it's doing everything. It's also answering the question for you. Like you could imagine an in-between, which is, imagine you're sitting next to like a Google search power user.
Yeah.
And so, you're typing in a query and you're like, oh, I don't really like this result because I'm seeing, I really would like to limit my like search to Reddit. And they're like, okay, cool, no problem. And they like go and like put the little filter in for you and then repeat the search. And then you're like, oh, none of these results, I need to limit what I'm looking for. I think it was written by this person, DK. They're like, oh yeah, no problem. And they help you out.
Right.
But that's where this like person next to you is helping take your feedback and refine the query.
Right.
But they're still pushing off the actual fulfillment of the query to the search engine. ChatGPT does everything. It's like you put in the words and it's re-looking through things, and it's all of that is impacting your query,
right?
Which at the end of the day is it boils down to a lot of vectors that then get remanipulated to inform what it spits back to you. And so, it's doing all of it, which is kind of what
is the length of like that sequence? Like if I assume if I just like refresh a ChatGPT, query interface, it's restarting from zero, right? It's restarting as if I...
So my understanding, like you can continue a chat today if you keep going on it, because it's when you type in something and then hit enter, it's folding together what you've done previously to inform.
And will it do the last 5 things, last 10 things, thousands? Like
so I know that like the Da Vinci model, which is that's GPT-3 on the API on their API, does 4,000 tokens is what they limit you to as your prompt and response, meaning everything you put in plus what you can get out is limited to that.
I see.
And then the other models,
4,000 tokens, and each token is
could be a word or a little bit,
or a little.
But it could be like 2 tokens a word. Yeah. It's at most a token is at most 1 word, so it won't be
at most or at least. Like if it's
one token, multiple tokens could map to a word.
Okay.
Yeah.
But usually no more than 2 or.
It depends on the size of the word, but it could be 2 or 3. But let's imagine it's just like between 1 and 2. So that's quite a chunk of context.
Yeah.
But that includes your previous part of your conversation and your prompt that you've just put in.
And the 4,000 is the things I've said, the things it said back,
correct.
The things I've said back.
Yep. Correct.
That whole thing is 4,000.
Yeah.
And is that because of like I assume there's a bunch of constraints around cost as well as performance, and is that like, would it be like dramatically better if you did 8,000 but it's just like not scalable, or it's just
so I think there's all sorts of tricks people do to deal with this. So there's limits at like different levels that kind of make dealing with the larger context you end up kind of radically different properties. So like theoretically you could have a larger context, but it might mean that you have to split the computation differently across how you're doing it with current GPUs.
Right.
And depending on where that split happens and how it's implemented, could end up with a radically different user experience, like orders of magnitude slower.
Right.
And so that is the trade-off is like, you're like, well, that latency would totally ruin the effect of this.
Yeah.
So therefore you limit the context. So the actual, in a transformer based architecture, the attention computation scales quadratically with this context size, the number of tokens. So every doubling of that increases the amount of compute 4 times. And the limiting factor at the moment is basically how like local you can keep this computation on a GPU. So that even if it's doing tons of computations, that turns out not to be the slow part. It's the accessing of the data to do the computation. So you don't want it to spill out into and have to go and fetch things from different
And
places.
that data is the 4,000 tokens data. If you had more, you might have to parallelize it across multiple GPUs.
I think I think they already do smart things around using multiple GPUs to do inference.
Mm-hmm.
But the point being is like, as you increase that context length further, you have to do more and more.
I see.
The complexity increases. There's a ton of architectural stuff people are trying to do where they can make so there's tons of tricks people do already around this stuff. So, and there's a few architectural differences too. So there's transformers where you can, they cache, computations they've done in prior windows to be available as like in an external memory for later windows, so that you can kind of imagine you're reprocessing 12,000 tokens.
Yeah.
As you sort of process, you do windows of this, but you are able to carry some opaque context forward.
So it's like a black box of state.
Yeah.
Like it's not as high fidelity maybe, or as expressive.
It's not interpretable. It's not like you can look at a table in a database and do a select query over it to see. Right. It's, but it's state from the attention mechanisms in previous windows that is then available in certain layers of the architecture to kind of look at again. Right. It's kind of like you're processing this context, and occasionally you're able to actually like pull in information from further back to bring in, and that can then give when you observe this in the product, the observation you can make is that sometimes information is correctly fed forward across many of these windows. In terms of the exact ways it's done with ChatGPT, I'm not sure. I think I'm not sure if they've shared that or not. It's just not something I'm familiar with. The most, there are more in non-generative models. There's simple ways of dealing with this too. If you're trying to detect something you're trying to extract, you can run it over separate windows and then merge the results in some way. I've seen super clever things people have been doing. Everyone's trying to work around this, by the way. So like products that were shown at the hackathon last weekend. The Founders You Should Know hackathon, this problem comes up everywhere. You're like, okay, I'm trying to do question answering over a document, and this document is super long. How do I do that? I'm trying to do search is another one. So I'm trying to retrieve a passage in my document. Some of the ways that I thought were pretty clever is that people have kind of manually forwarded context as they get the like model to produce a summary that is then like prepended or appended, depending on how the prompt's constructed, into the prompt for handling the next section. So it'd be kind of like reading a book and keeping little notes that you then provide for yourself as you read the next little bit. Right. So you're like, oh, these characters, I've seen these people, this is what's happened, and you forward it forward again. But again, you get the system to do that summary, and it's all natural language, which I just thought was like very clever.
Is that usually done? I mean, in the book example, it almost feels like you would do it trying to almost use theory of mind or kind of write a little bio about each character to carry, because that's what we do when we read. We're carrying the bio and the what's going on in their head and what happened. We're carrying that forward, the detail of how we learned that the person likes grape juice or whatever.
Yeah, well, I think that's where the formation of the prompt to carry that context forward ends up actually being really important, and again, context dependent in terms of what you're trying to do. As you sort of process more of the document. But I think what I thought was just like pretty cool about this was it's just people coming up with these ideas. Like everyone's trying to work around these like context points, and I think the context limitation will exist to some degree for a long period of time. And even if it didn't exist, the compute's going to scale in some form or another as document or text length increases in terms of what you're trying to do. But there's some wild bits of research that go in like a totally different direction. So a lot of people are trying to pull knowledge out of large language models, or at least have it so that they can supplement them in some manner. There was like a really fun bit of research, I think it was last year or the year before, where they kind of flipped this on their head and said, what if we tried to put all the knowledge into the large language model? So we make the large language model a search index. So you give it a query and it generates a document ID. That's like...
Wait, you're giving it a query... This is in a training phase or in a query?
At training time, you're getting it to try to predict the document that would answer their query.
But
not
training,
the answer.
Usually the query comes kind of at runtime or right at inference
Yeah,
time.
so the training examples you would give are batches of queries.
I think these are the kinds of things people are probably going to ask for.
Yeah, exactly. Just lots of those, lots of questions, and then an identifier that says which documents it's in. And then at inference time is where, you DK, go and ask the system a question, and it spits out the document. And so the funny thing about this work is that at query time, at inference time, you've got a known amount of computation you're going to do. Your query plan is identical. It's like you put the query in and it goes through the transformer, however long that takes, and it spits out a document ID. But what's interesting is the system internally has been, the hope is that it's coming up with useful representations in this big latent vector space of both queries and documents, so that it can answer questions effectively in this like fixed compute budget. But that's kind of fun. It's a little bit different, and again, there's all this like future work of like, well, how would you like, imagine I go and update a document and like remove a paragraph. Yeah. How do I update this system effectively, et cetera, et cetera. But it's fun that these different avenues are being pursued. But again, that's the reason I brought that up, was that's again where you're taking this approach of like, let's not try come up with the optimal, what we think, or interpretable representation of our information to look at. Let's instead just get the system to try to come up with that based on the kinds of questions we think we might want to ask. Right. And it's kind of fun because, if you ask lots of questions about people, maybe the internal representations will end up, identifying that there are certain people and representing them in a certain way, but you haven't had to come up with it.
So having that kind of a priori knowledge about what may be queried in order to use that to train kind of makes me wonder about a topic that seems to be coming up a lot, which is, obviously like the stuff that we see in large language models and GPTs and chat are impressive, and I think has everybody leaning into like, okay, everything's solved, what's next, kind of, which, obviously is a kind of a dangerous assumption to make. But I think a lot of people are sort of saying, okay, these platforms have built these great horizontals out, and they'll just keep getting better. And now we're going to build verticals on top of those platforms. So we're going to take all the amazing generative stuff that you can do, and we're going to do like the legal, the law firm version of ChatGPT, or tuned for the utility of a law firm, or we're going to do it for the utility of like a customer service, employee base, or kind of. Yeah. And, I think it sounds like, I think the horizontals are interesting but imperfect, and it feels like we don't have even enough knowledge to really control or understand exactly what they're doing or guide them in the ways we might want. So in your opinion, and there's a little bit of a future, but is it worth exploring? Like, do those verticals help constrain problems enough that they may be more solvable?
Yeah,
now?
I think they will. Yeah, I definitely think. I think it'll be within certain verticals where, again, this is where I think, like, I'm not a lawyer, so I'm not about to go tell someone how ChatGPT will apply to law. Honestly, I think that is the huge magic though of ChatGPT, is that a lawyer who has no technical experience, but is like a lawyer who've been training for years and years and have just a ton of domain expertise that, someone like myself does not have. Yeah. They're able to be the judge of the efficacy of this technology or not. And I'm sure an enterprising lawyer will figure this out of where there's opportunity, because they're going to see opportunity domain-wise. Yeah. That someone who's more technically focused and training and has not spent the time in that domain won't see, just in the same way that like I'll see an opportunity technically that someone who doesn't know the details does. So I expect there'll be more uses of this at those points vertically where people see opportunities that allow them to deal with this imperfectness, but it helps them in their process in some manner. Right.
Because I'm not a lawyer, but I could imagine, I've worked with enough lawyers and seen that you get all of these documents that are basically kind of all the same with a little bit of changes here and there, kind of replacements. I think mostly an associate ends up working on this, but it ends up going through the eyes and the stamp of approval of a partner.
Yeah.
So you can imagine that maybe the GPT or kind of the vertical LLM focused version of this functionally is doing a lot of the work that the associate might otherwise have to do, which is not necessarily the most creative, interesting part of the work. And it still maybe gets reviewed by the partner before it gets shipped out. So
yeah, I mean, maybe like if it's the case that like I don't want to oversimplify because something from the outside can look simple.
Yeah.
Yet it can be difficult. Driving is
Yeah,
a good example.
yeah.
From the outside, it's like, oh, you just do it.
Yeah.
But it turns out we're doing a lot of things in our mind how we drive that turn out to be very difficult to make explicit or engineer, and that's hence self-driving is a challenge, and absolutely progress is being made, which is super exciting, but it's harder. And so just because it's something that seems like a skill that's more accessible to more people, like in the case of the law firm where an associate does it, it doesn't necessarily mean it's readily automatable. But again, this is where I think vertically, someone who's more in the know or more enterprising, maybe it'll be an enterprising associate who's like, you know what, like if this, like, I feel like I could help myself here. Maybe they come up with a very clever way to like address the 80% of what they have to deal with. And they've got enough knowledge of the process to think about what would be a UX that would be great for them. That's, I'm excited by that. Like that, because not from the perspective of like, oh, it's just from the perspective of someone who's now become more empowered. Like, I think that's the difference between ChatGPT versus, like the OpenAI's like playground versus like Hugging Face transformers. The level of accessibility technically kind of decreases. The accessibility decreases on each one, and ChatGPT, I think, really kind of opened things up there. So I do think the vertical place will continue to, there'll be these applications people find. I think the platforms horizontally will get better and better. I think on the like headwind side coming all the way back, I think it's, I'm so impressed by the conviction of leadership and the team at OpenAI, because it definitely wasn't clear that scale and making the bets that they made would actually, like, it's a big bet they made.
Yeah.
They spent like a lot of money, a lot of people, a lot of time.
2017, 2018 or?
Yeah, but GPT-3 I think first came out in 2020.
Yeah.
And initially you're playing around with it, you're like, this is a joke. Like this is, how can this be? But again, some people vertically saw it, like folks with marketing expertise. The CEO of Jasper, exactly, like marketer by training, and is the one who sees the opportunity there. But then the conviction.
Do you know how that all came together? Like,
no, I have not. Yeah. Do you know? Is there?
No. I was just curious because I wonder if it's somebody who was from marketing who happened to see an early example, or how.
So I'm pretty confident that I'm remembering this correctly, but the CEO and founder of Jasper is a marketer by training and was the person who saw like enough early promise.
That's cool when you can kind of connect the dots and make that bridge.
Yeah, and that's super interesting from their perspective too, of seeing like enough into the future to make that bet too. And on the OpenAI side, around just pushing to keep doing these training and experiments. It's not cheap or straightforward, and again, just every part of it. So that's the part I'm just massively impressed by. I think the challenge will be though over time is, I don't like just. It'll be interesting to see if we just if the amount of data, the size of these models keeps getting increased. What does that like asymptotically look like in terms of a usable API for scaling up a process? Because when I kind of draw a parallel back to like writing some functionality in software, I am okay with calling a function an infinite number of times because I've codified at some point what I expect from it. And I codify that in my tests, and I have a kind of clear understanding of how it operates in its interaction with other things. The challenge over time that these AI systems will have, especially ones like prompt driven. So I don't think prompt engineering will go away, because you've got something that's the only place you get to specify like your controls, your parameters to this function. Like you're effectively changing the function by putting this prompt in. So I think prompt engineering, I think it'll be hopefully over time less like I'm not like cryptic looking. You know, if you look at some of the prompts for like Mid-Journey, they're just wild in terms of like what people have figured out to put in. So and the same is true with the GPT models. So I think over time, like prompting will become a bit less archaic looking, but will still absolutely be necessary. But the challenge will again be guaranteeing, like establishing the guarantees you need to productionize, to use it at scale. And that using it at scale is important because that's the part where you actually get leverage as a software company or at a level of automation. So that's why I think all these verticals where they're focused around people first and improving some process there, I think are they're very promising.
How do you think about sort of, I mean, you came from this 2D, 30 dolphin visual world, and we haven't talked that much about sort of Impira and what you've been focused on there and what that journey has been like. And then there's, so much attention on AI today and, different forms. And obviously it's stuff that you're engaged with and playing with, but like, how do you think about the next, 1, 5, 10 years for you? And are you going to choose a problem space to sort of navigate to that is just near term technically interesting? Or are you looking at something that within a 10-year time frame, it has to have a certain impact? Or how do you sort of think about it?
Those are awesome questions. So my, I guess, like progression through from what I worked on during my PhD was it was more generally looking at 2D and 3D representation and resolving these models.
Mm-hmm.
One of the applications was dolphin stuff. My actual thesis was around medical imaging, so a lot of stuff there. But the kind of key thing I got out from it and the sort of broader experience and learning from the people around me was I spent a lot of time working on these optimization problems and like the practical aspect of kind of methods and engineering around it, which kind of gave me enough confidence to then, as deep learning stuff kicked off, there was a lot that looked familiar and a lot, again, modeling wise, that looked then a little bit different.
Mm-hmm.
So then kind of pick up and learn. As that's like looked application wise in terms of like where I've worked and like what I've spent my time on. So I joined the company Primer when I first moved out to the Bay Area, was there for 2 years. And then...
Oh, is that how we're originally connected?
That's how we're originally
John Bohannon?
I met John at a Christmas party. Yeah.
Oh, fun.
When the company was initially just 5 people.
Oh, fun.
There were not enough people and spouses to make the Christmas party feel
festive enough.
Exactly, festive enough. And so John was invited by Sean, the CEO, because they were friends from a long time back. And so that was how I first met John. I think it was in Christmas 2015 or 2016. But that was initially how him and I met. And so I worked there for several years, and then worked at this company Impira that started in 2017, and at the end of last year we were acquired by Figma. So that's where I'm looking to start next. But at Impira we worked on this problem of started with kind of a very broad starting point of trying to build a database for unstructured data. This idea of being able to make as easily as you make a query on your like SQL database, and the flexibility you have to try to do something similar around data, very, very broad. And we started initially in use cases around what it's called digital asset management and product information management. So that's where larger companies, so like could be consumer goods companies, or so it could be like Stitch Fix or Colgate, where they have a ton of products and imagery and assets around it, and quite complex queries that they need to ask to find things or make use of things. That's what they would...
Is for like analytics and stuff, not for running the core website?
Or something? Could be for both. So like, for example, at Stitch Fix, where this has been used, was they have to generate as part of their product a ton of imagery around their clothing, because the stylists have to see what that looks like to try to make a suggestion then to the consumer. It's really, really neat in terms of how it's done. And then they have a lot of merchandising information where it's, how many, how many of each product do they actually have, like what are they going to be buying. But then, so they generate a ton of imagery, which is expensive to generate, just because it takes time. You've actually got to like put products on people or pin it up and take a picture. And then you've got all this data around merchandising, which your merchandising team, their business goal is around actually making sure they buy the right stuff and they have it in stock. But then you have a marketing team, which has to generate content to try to reach out to people. And, it's not great if you go to reach out to someone and you show them a picture of a t-shirt that you no longer have in stock.
Right.
Or you, show a picture with a person in it for which you no longer have a contract to show them that picture in. And so where the big use of Impira has been at, say, like Stitch Fix, has been the joining of this information together so that they could actually do really powerful queries over their images. Like, hey, find me like red dresses which are of this brand and there's like this many in stock.
Right.
Where it's able to blend the query that ultimately fulfills this and gives them back these images is blending properties of the image and product information.
And that'd be used by the stylist to
that would be used,
query.
More so on the marketing side. And I think I think that was the primary piece to start with.
Right.
So for just downstream content generation from this. And so I think that was the kind of the key piece though, was this ability to query across both and again merge properties that come from the picture, which again includes metadata from cameras, but also includes vision aspects as well.
Right.
Take a company like Colgate, things are similar but different. So it's like you have pictures of products, and Colgate Palmolive being the gigantic conglomerate that has Colgate Palmolive, and then tens of other, or maybe hundreds of other brands under it, has to manage product imagery and associated product metadata across several languages, and their information like structure as companies is set up largely to support their actual production of goods. But again, it becomes difficult for, say, someone in marketing to make queries across this.
Right.
And so again, that's the kind of use of this initially at Impira. Then we pivoted as a company. We kept seeing this aspect come up where information was needed out of documents, whether it's like a contract for a model, like a person model at like a Stitch Fix or equivalent, or re-looking at packaging information. So, companies like big consumer product good companies will outsource parts of, or at least like it's complicated, basically what gets put on your toothpaste box. So like their lawyers will look at the claims made, like, can we claim that it's going to make your teeth like 10 times wider? So that's fine. They might get everything signed off by legal, but then they give it to me, the graphic designer, and I'm like, oh, this would be way better if it's 100 times, and I go and change it. That's bad. So occasionally they'll actually have to like relook at their own things to double check that it's passing with legal. But we kept seeing this problem come up of pulling information back out of documents, and that's what motivated and a level of flexibility needed around what's being extracted. And that's what motivated the second version of what we built at Impira, which was this platform for you can upload documents via the API or the UI, and then you can start selecting what you want to extract out of it. So you get to create, it's actually like a database from the perspective of your files end up corresponding to rows.
Right.
In what you see in the UI and in the data model. And you can then add fields like as if you add columns, but you can populate them from data in the document. And the system will learn small models based on these points of labels and then generalize to other documents. And so the system is excellent at like structured, PDFs, for example, that people have. We had like a COVID testing facility, just like sign up. They had some forms that they needed that had been like filled out that they needed to process to get some reimbursement by a period of time. And that was great. They like got it processed.
So you ingest those forms.
They ingest the forms. They highlighted like a few things they needed. It then got the rest of them out. Then they just download a CSV and they're done. And that's, that's like a very simple case. But the reason for what's exciting, what was neat about this is so we went down this track. Again, this was like technically 2019 or so. So results around like Transformers was just kind of coming together, but did nothing like the kind of excitement nowadays. But at the time, like the biggest thing we were looking towards was like interpretability around how these models could be tailored on a per document or
Yep.
class of document basis. And we really wanted them to be interpretable for this perspective of being robust for higher scale documents.
Mm-hmm.
So people could, if they put documents that looked similar to them uploaded, the system would extract with high confidence.
Yep.
And that's really kind of what motivated and was the core of this product that we've been developing the last several years. And then last year we put more of a focus on, so one of the challenges of the product was, just like every product, is onboarding. How do you get someone new?
Yep.
And it's like a database. I think there's a good analogy with databases where NoSQL databases are lovely from the perspective of you're like, oh, I have some documents, I just like push them to the system, and the system's like, don't worry about a schema, like we'll figure that out for you. Like you don't, it'll have like various degrees of constraints it puts on you, but you don't have to do a lot of thinking to getting an initial result.
Mm-hmm.
Whereas if you say start with like Postgres, it's like a blank slate. It's like, hey, what are your tables going to be? What are the types of your fields going to be, etc. We were more like a Postgres to start with. So you start with a blank slate and you're like, what are these primitives in Impira that I have to deal with before I can just like upload a document and pull it out? And so we spent a lot of time on simplifying onboarding so you could start with a document and see results without having to put even a single label.
Colgate or whoever, you upload a document and then you start to, you're doing the highlighting, or it's the system's figuring out?
First, like this work we did a year ago, you sign up, it's just a blank slate. And then you're like, oh, I've got my forms I want to upload. You like upload them and then you start highlighting, and the system in real time then generalizes across the other ones.
I see.
So the actual infrastructure to do this is pretty neat because it's recognizing like when it needs to refit these like smaller models, and then as those are getting refit, reevaluating, and then reindexing everything else. Because again, after you've done this processing, you can do other queries in the system. You can do things like extract numbers out of your documents, and then put a query in that says like total it.
So you have like a very highly structured model of what all of those form
the user has to have that though.
The user has to know that.
The user has to know that.
Do they have to create?
Yes, they do. So the upside of this was like where we saw saw a ton of success with this, where users were very clear about what they wanted for a downstream system. So they're like, hey, I've got these like PDFs. And these could be, sometimes they're just enormous. It's like, hey, I've got this like 500 to 1,000 page PDFs. I've got like, tens of these like every week or so.
Yep.
And we need to pull out the line items from these these are the key fields because this is going to power some downstream system.
Yep.
And it was beneficial for them to describe these types. They're like, I want like the data field, each field to have like this type, some constraints on it, and this is what's being extracted. The downside though is that first user experience. I have an invoice and I come to the system and I say, hey, Impira, like analyze my invoice.
Right.
I don't even know what fields I want out of an invoice. I just like assume there's
You've never seen what it does. Even.
And so this was where the team did some amazing, like the team on the product side and everyone involved there did some really amazing work on really engaging with this problem and improving it. And on the machine learning side, we did our first like major foray into transformer-based models to do this extractive. We still trained a pretty general model, was actually the pretty neat thing about it. So you could basically ask a question and put the process document into it, and the system will output where it thinks the answer is within the document. So if you say like invoice total question mark, it'll like point towards the words where the invoice total is. Right. And so this allowed us to
and this was, you said 20...
This is last year.
This was, 2022.
2022 was the kind of major...
and were you were taking... These are like language models that you're training from scratch to solve this?
Yeah, so the first version of this... and we've open sourced this on Hugging Face as well. So this is under what's called the like doc QA, I think our space is called. And there's been a few things that have now upstreamed into the Transformers library as well. The actual architecture for this model is relatively straightforward and is from Microsoft originally, I think. It's called Layout LM, and it's very close to BERT as a language model. The main intuition or difference is that with language, if I give you some paragraph, you don't care whether it's printed on like letter or some smaller type. You don't care about the geometric position of words.
Yeah.
Whereas for a form or some broader document that may convey information that's important. Same with like the size of what you're extracting, you know. So imagine the invoice total is always like super huge, or there's like geometric information. The key point is that it's important. And so layout LM, the kind of big intuitional difference compared to just straight BERT is that it takes those geometric positions and includes them in the vector at the first part of the neural network. There are some minor differences internally, but that's the long and the short of it. So
would those ever get converged? Because it seems like your application was very specific on forms, and then maybe BERT stuff is more, agnostic of the geometry, but maybe there's examples where BERT will get some advantage from it. Right?
The intuition, I think, driving the question, I think, is a really good one, which is like, it seems like question answering could make use of geometry, but also doesn't need to make use of geometry. And that was a big part of like our training process for this model as well, which again, I think we made clear on the open source point, if not making it clear now, which is, we trained on a mixture of where we actually, in our case, like synthetically just like generated the documents from plain text. So imagine I take some article with questions I already know about it. I just generate a document. So I give it some geometry with some noise around that, and then include that as well. So I think the things I look at on all these things now is, can you separate modeling decisions, so like parts of the architecture, versus like the data decisions that go into training it. And so the way to think about this like form processing type work, or a way of like thinking about it here, is just that the geometry got added in as an extra signal, but that didn't mean we couldn't utilize data and training processes around just kind of plain text as well.
Right.
And so that was
2022.
That was 2022.
And then that was also, you said that was the year that you and Figma.
Yeah. So that was announced, I think, at the end of 2022, or I believe so, or the beginning of 2023.
Just a
it's
month
very,
or so
very
ago,
recent. Yeah. And so.
And how was that process? Like, was it something that you guys had already been talking about, and you knew a specific application of the layout technology within Figma, or more like how did that all come together?
Broader piece is just a lot of time spent around modeling, productization of it, and the kind of technology infrastructure, and where we're at in terms of a company. Impira was not large, as 20 or so, I think, at the time of this going through. And so that is the kind of key piece of kind of what made this sort of exciting and where there's a fit. I'm super excited about the opportunities at Figma, just because of the fact that it falls into kind of that category I talked about earlier of, there's this product that has an amazing, first of all, it's like an amazing product.
Yeah.
It's just very well engineered and is very fast. And so for those development loops that someone goes through as a designer, or someone who gives comment on designs, it's just incredibly exciting.
Yeah, totally. I've used it for years. I love it.
Yeah, and as a platform, it's incredible because, again, your effort inside it compounds. One designer does work on a given component that someone else can then leverage, that then a third person can put in part of a design system. All of these parts are really exciting to me from the perspective of being able to deploy automation in ways to augment what people do already and facilitate more and more kind of communication within the product. So I'm excited by the opportunities there product-wise to have like a really like positive and like just exciting product impact in a way that's like orthogonal and very complementary to what's already there. I see. And excited to learn from the team there as well.
Yeah, and I've used the product for years, and I've never seen anything that would appear to have any of this world, any of the LMs or anything in it. So is it accurate that they've not focused on this at all, and now the Impira team is going to be the ML team?
Yeah, so
Figma, is
that's right. That's like we're starting that off, and then we'll be, that team will be growing and those things. And I'll be starting in next week because I don't have a green card, so I have to wait until my visa was approved and all those things. But that's the long and the short of it. And I think there's parts of Figma that absolutely have looked at little bits and pieces but they've been laser focused in terms of developing the product to the point it's at, scaling it to the point it's at, developing FigJam and those pieces. And so I'm impressed by their focus.
Yeah.
Because these, this like LLM based stuff it'll take time, and it'll take a lot of product iteration. It'll take a lot of like input from kind of everyone to make these things exciting. So it's I don't think they've done major things already, but they've had enough on their plate with making the product work to tons of people and the level of scale that they do now. So
and when I think about ML in Figma, outside of this conversation, I would have guessed like, image generation, clip art, kind of more the visual side of it that we talked about before. So is that also stuff that you and the Impira team are excited about and Figma's excited about?
Yeah, I think there's a lot of product ideas floating, all the way from helping users do what they need to do today more quickly.
Yeah.
Some to like softening rougher edges of the product, or again, those little assists, kind of like in the way Copilot can assist you at times. I
would love, like, I'm good enough at Figma. I can like communicate an idea, but I struggle with it. Like I'm not a proper designer, right? And so I would love to be able to use language and just say like, I want it to be like that or that, almost like I'm speaking to somebody who actually is a professional. And then it kind of does the right thing, probably at a higher level of fidelity than I could do.
For sure.
And probably instantaneous or within seconds instead of
hours. And this is the thing to explore, is like where that's possible, where it's also effective from it's all to support the designers at the end of the day. So I could imagine a similar thing you just described, but from the commenter, hey DK, like, can you make this look a little bigger or something like that?
Make it pop.
Exactly. But again, I think the key thing will be and where the team I know is spending time already is like understanding where there's going to be benefit. And again, just making sure it's really mission aligned with like what the product's doing. This is all, needs to be complementary, needs to be well aligned with kind of those kind of points of product direction. But I think what is exciting to me is that the product itself is already such a great place for iterative development. So it has this, again, if done like tastefully and well, I'm really hoping we can do some magical things on the machine learning side, because there's room for mistakes if your suggestions can be well handled or disregarded or whatever. It's not the same. And again, we've already got this person in the loop there, whether it's the designer or the other collaborator that they're working with. So.
That's great. Well, I don't want to ask you to reveal too many of your secret plans. So.
I mean, I think at the end of the day, like, ideas are relatively cheap. It's about how you like have to like actually go after it and do the work. And again, I think everyone's got ideas on stuff, but it's super important to learn from everyone kind of already there. And I'm excited to learn from how the system's built, how they achieve what they do, and also like learn from, again, all the product feedback they get at a massive scale.
Totally.
And what their directions are too. So
well, it's already an impressive product. So I think when you sort of start to layer in these newer technologies and stuff, you can really take, get these new technologies broadly distributed very quickly to lots of people when you find something that
exactly. So we'll see. It should be a bit of fun. So
all right.
In terms of what things then look like longer term, I'm not sure. I mean, I want to be there and just have a great impact and do good work. I think I'm excited by the technical and kind of product piece. Like, I think definitely I think it's hard to make decisions in complete isolation. Like, if you make a technical choice, like you choose to go down a certain route, it's going to have trade-offs that will very much impact the viability product wise or what other interactions are needed. And that's something that I personally am just keen to kind of keep developing and learning around. I'm excited to see little and big applications of all this LLM stuff pick up in various domains too, and just keep learning. But I think I'm just like everyone else. Everyone's just trying to figure it out. Make forward progress. So
awesome. Cool. Well, why don't we take that as a stopping point? Is that good?
Yeah, perfect.
Okay, awesome.